Welcome back to my channel. I'm Pravansh Kumar Singh, and today I'm going to continue the Node.js core concept series. And today I come here with the new topic called Libuv and the event loop. We'll talk about the Libuv and how it handles the asynchronous task, and then we'll talk about the V8 JavaScript engine, where how it handles the execution of code in the call stack, and also we'll have little brief explanation about the memory heap that is available in the V8. So this is the Node.js architecture where we have JavaScript libraries, C++ features, and then dependencies, the V8, Libuv, zlib, crypto, and etc. Where the main dependencies are V8 and Libuv. The V8 engine is responsible uh, for memory heap and the call stack. So memory heap is the place we assign any variables to some data. It gets stored in the memory heap. Now in call stack, the execution of the code happens. So every line of code in a program get executed in call stack. Now Libuv is responsible for the asynchronous task. So call stack only execute the synchronous task by blocking the main thread, whereas the asynchronous tasks get executed in Libuv, making sure that the main thread will not get blocked. Libuv is the support library, cross-platform support library, which is built originally for Node.js. It handles the asynchronous event-driven input-output mechanism, but it not only handles the asynchronous input-output mechanism, but also it handles the other entities like handles and streams of the Libuv. It provides the higher level of abstractions for sockets and entities, other entities. File input output mechanism and threading are the other functionalities provided among the other things. Libuv provides the user with two abstractions. One is handle, another is request. Handle is a long-lived object capable of performing the operation while it is active. For example, a prepare handle call is callback every iteration of the loop. Similarly, a TCP header handle calls is connection callback whenever there is a new connection. Now we'll see the request. So request is a short-lived operations, and it is operation over the handles. So for example, the write request is used to write the data in a handle. Now let's see how synchronous tasks get executed and asynchronous tasks get executed in Node.js. So right now we are going to view that how synchronous tasks get executed. while While the execution of any code, first of all, the global function get called, and it is the function that is already available in any script. We don't have to write this one. If we are basically calling a particular function, that function will come as the name. So we'll see here, since it is a synchronous task, the main thread will execute all the tasks one by one in a sequence. Here, none of the tasks get overloaded to Libuv. Now we'll see the asynchronous code execution in Node.js. We have the line number 2, which is fs.readfile is a asynchronous code, and others are synchronous code. So we'll see now the synchronous code get executed in a sequence in the call stack, while the read file, which is a asynchronous code, get overloaded the Libuv. And when the Libuv completes its execution of read file, then the callback is pushed in a callback queue, and once the call is stack is completely empty, then the task from the callback queue get executed in the call stack, and it prints the console console log second. So we'll see the first and third get executed instantly from the call stack. That's why it's coming in the first and second position. And the second get print because in the last, because it is inside a callback of the asynchronous task. Now we'll see how event loop works. So obviously we are going to discuss about the macro task and micro task in the next session, which will give the more in-depth knowledge about the sequence and the priority related to the event loop. But briefly we'll see here how event loop works. So inside the event loop, there are majorly five kind of callbacks. One is time series callbacks, another is input output callbacks, check callbacks, and close queue close callbacks, or we can tell it close queue. And then there is a micro task queue. So time series callbacks contains the set timeout and set interval. The input output callbacks consists of file system input output mechanism, network request, those things. Set immediate callbacks contains the set immediate functions, and the close queue or close handlers is capable for continuing or exiting the event loop. The microtask queue consists of the promises and the process.next state. So process dot even inside a microtask queue, process.next has a higher priority of execution than the promises. Now for other queues, it will executed in a particular fashion. Like first of all, the time series functions get executed, and then input output callbacks, then the check queue set immediate functions, and then the close handlers. So we'll see here how the event loop works and in which fashion. In more detail, we'll see in the next session when we are explaining the micro and macro tasks. If you really like the video and find this video valuable, then please hit the like button and subscribe my channel. Until then, keep coding, keep exploring.